Hello, this is my first video on classical mechanics series. This is going to be just an introduction to classical mechanics. So if you already have a good introduction, so you can skip it. So without wasting time, let us start. So the most basic concept in physics is the concept of physical quantities, and these physical quantities are mass, length and time. The world in which we live and the world which we observe through our senses is called microscopic world or the middle dimension world. It is called middle dimension because the ranges of physical quantities in this world are in between their extreme limits. So I will explain it as we go along. Okay, so to answer this question, why our world is called middle dimension, we should first look at the ranges of physical quantities. So on the extreme left column, I have put physical quantities with their units, and in the middle column contains the lower limits on these quantities, and the extreme right column contains the upper limits. So here you can see that the smallest mass that we are capable of measuring is somewhat of the order of 10 raised to power minus 31 kg, which is the mass of an electron. And similarly, if we see the upper limit, so the upper limit on mass would be the mass of entire universe. And for length, we see that the lower limit, the smallest length that we can measure experimentally is the length is of the order of 10 raised to power minus 15 meter, such as the radius of a proton, which is of the order of femtometer. Similarly, the upper limit would be 10 raised to power 26 meter, which is the radius of entire universe. The last is time. So the smallest possible time in universe is the Planck's time. It is theoretically calculated and it is equal to 10 raised to power minus 42 seconds. And the upper limit on time is of course the age of universe, which is 10 raised to power 17 seconds. Okay, so the next question is, what is the observable range? By observable range, I mean the range of a physical quantity which can be measured without any physical instruments. So if we see the mass, so the lower limit is a fraction of a gram and the upper limit is 1,000 kilogram. These masses can be measured and observed without any physical instruments. These masses can be estimated. These So the next is length, and the lower limit on length is 10 raised to power minus 4 meter, which is a fraction of a millimeter, and the upper limit is 10 raised to power 4 meter. For time, we have lower limit as 10 raised to power minus 1 second, which is just a fraction of a second, and for upper limit we have 10 raised to power 7 seconds, which is 1 year. So it is simple. A person can tell you the difference between 6 months and 1 year, so it means it can be approximated. So why our world is called middle dimension? So now the answer is quite obvious. The range of physical quantities lies between extreme upper and extreme lower limits. For example, in the case of mass, we see that the lowest possible mass was 10 raised to power minus 31, and the highest possible mass was the mass of the entire universe. But the observable range is very small, which ranges from a fraction of a gram to 1,000 kilogram. So this middle dimension world is the regime of applicability of classical mechanics. So now you can see these objects. So these are middle dimension objects. These are macroscopic objects and we can study them using classical mechanics. For other dimensions, we have other branches of physics: quantum mechanics, quantum relativistic mechanics, and quantum field theory. So So this diagram explains the regime of applicability of different branches of physics. So the vertical axis contain mass. I'm sorry, I forgot to put the label on axis. So this vertical axis contain mass, and mass is increasing in the direction of arrow. Similarly, on the horizontal axis we have speed, and speed is increasing in the direction of arrow. So for sufficiently large masses moving with speeds very less than speed of light, we have classical mechanics. So if these large objects start moving with the speed of light, moving with the speed comparable with the speed of light, then we have relativistic mechanics. Similarly, if we have small masses which are moving with very small speeds, then we are in the regime of quantum mechanics. So if these small particles, these quantum particles, start moving with relativistic speed, then we are in the regime of quantum field theory. So if some physical laws are valid in middle dimension, then there is no such reason that they should also be valid in other dimensions. That is why laws of classical mechanics are not applicable in quantum and relativistic regimes. Okay, so this was just an introduction to classical mechanics, and if you are watching it on YouTube, then thank you so much for watching.